In the second category of application layer protocols, we're going to talk about protocols that are used to provide IP addressing services like DNS and DHCP. DNS, of course, is used, or domain name service is used to map a specific domain name into an IP address. Because, of course, as we can imagine, it's easier for people to exchange names of servers rather than exchanging IPs. So it's impossible for us to memorize the IP addresses of all the web servers that we communicate to. And instead, what we do is that we type the domain name on the browser or from any client, and then the client will actually request the IP address that corresponds to that domain from the DNS server. So the DNS server hosts a lookup table which maps any domain name like cisco.com to a specific IP address. It starts by the client initiating a request using the domain name in the request message, and then the DNS server will respond with the specific IP address. If the domain name server does not have the IP address that corresponds to this particular domain name, then it asks another DNS server in a recursive form until it gets the IP address that corresponds to this domain, as we will see in a minute. Then the client will fetch the IP address for this domain name, and then it starts using any protocol like HTTP or FTP using the particular IP address as opposed to the name. Of course, the request of the DNS, the request message of the DNS has certain format that includes a header and a body which includes a question and so on. So to get all the information about this message and the details of it, you can try a simple command like ipconfig/display DNS, and this will give you all the information about all the servers or the domain names, and it gets you the information or the details about this, including the IP address and so on. So this is the information for the servers that are cached in the client or on my machine. If I type a domain name which does not exist on my machine, then I have to request that from the DNS server. And if the DNS server does not have this information, then it asks another DNS server in a recursive format. So this is how it looks like. So the DNS client will send a request to the local DNS server. In that case, this local DNS server exists in ITS in the case of QU, and if that domain name exists on this DNS server, then it sends back the IP to the DNS client, and then the client will use that for communication. If the local DNS does not have the IP corresponding to this domain name, then it sends to another top-level domain servers, and these top-level domain servers are, for example, the DNS servers on the service provider level. On the service provider level, it contains all the domain names that are existing in a specific country or a specific hierarchy like .com and .org and things like that. And if the DNS server in the top level domains does not have this information, then it sends to root DNS servers, which are hosted by tier 1 service providers. And these tier 1 service providers, they offer like root DNS servers which contain information about how to get the IP address that corresponds to any domain name on the internet, or at least it knows where to get it. So in that case, when the DNS server initiates a request, it goes recursively to multiple levels of DNS servers until we hit a server that has the IP address that corresponds to this domain name, and then send it back to the client. So in order to see if you have the IP address that corresponds to a particular domain name or not, there is a simple command that we can try, which is called ns lookup. So the ns lookup gets you in the DNS prompt, which you can type any domain name like this, and then it gives you the IP address that corresponds to it. Not only the IP address version 4, but the IP address version 6, as we can see here. And sometimes it gives you multiple addresses if that server, like google.com, if it has multiple IP addresses, like for multiple servers, if that website uses multiple servers, then it gets you the IP addresses of all these servers. So that's how we tried this command. So you enter here and you then you get all the IP addresses, not only IP address version 4, but the IP address version 6. And then if you finish, just write exit and you get back to the prompt. DHCP, well, Dynamic Host Configuration Protocol service is used to enable the dynamic assignment of IP addresses. And when we start our machines, we activate the DHCP client, which tries to fetch an IP address from the DHCP server, which exists on the network, or it exists on anywhere, whether inside or outside the network. So first it starts by sending a broadcast to all the servers or to all the machines on the network to ask if there is any DHCP server, and then the server will send back a response that I'm the DHCP server, and then it offers certain range of IP addresses that the client can then select one IP address from this range, and then the server will lease or will give this IP address to the machine. The advantage of this DHCP over static IP address is that if I assign static IP addresses on all the machines on the network, then I may actually dedicate an IP address on a machine that's mostly turned off, and in that case this IP address will not be used efficiently. And then there are some other machines that starve and they don't have any chances to get assigned IP address, in which case the IP address exhaustion will happen on the network faster without using a DHCP. The disadvantage for this DHCP on the other side is that by assigning the IP addresses dynamically, we may actually get a different IP address every time we start, in which case our client or our machine may not necessarily act as a server, because a server needs to be exposed on the internet with a unique IP address that's known to the client. So if the client tries to connect to our machines and our machines has a different IP address, then the server on our machines will not be exposed on the internet, in which case the server will not work. So the way that DHCP works is first the client will send DHCP discover message. The DHCP discover message is a broadcast message to all the machines on the network to try to find if there is any DHCP server on the network, and if there is one, then the DHCP server will send a response in the form of DHCP offer. The DHCP offer message will contain confirmation that this is the DHCP server, and it will also send some range of IP addresses as a lease to the DHCP client that the client may select from. Then the DHCP client will send a DHCP request which tries to select a specific IP address from the DHCP server, and it tries to request to lease or to get this IP address for a certain range of time. Then in that case, if the DHCP server can grant this request, then it sends a positive DHCP acknowledgement with a confirmation that this IP address is already assigned to this machine. Or if there is any problem or it cannot assign this IP address to the machine, then it sends a negative DHCP acknowledgement, in which case the client will have to request another IP address, or may actually go to DHCP Discover to try to discover another server or another range of IP addresses that it can select from.